On April 20th, 2010, the Deepwater Horizon disaster changed the lives of millions living near the Gulf of Mexico, as well as the scientists who responded to the crisis. These are some of their stories, intimate portraits of research, innovation, discovery. Welcome, I'm Jim McNamee, editor of Dispatches from the Gulf, a series of documentaries, short videos, and podcasts. In today's podcast, we'll hear from atmospheric scientist Rafaelle Montuoro. Dr. Montuoro uses supercomputers to run complex numerical models of ocean and atmospheric systems, called coupled models, to see how they interact. Although it's not quite rocket science, it's just about as complicated.
My name is Rafaelle Montuoro, and I'm a research scientist in the Atmospheric Sciences Department at Texas A&M University. I always wanted to be a scientist. I wanted to be a scientist since I was probably 3 or 5 years old, and I was always interested in understanding how things worked, and I used to draw blueprints of, engines and things like that. At some point, I wanted to be a rocket scientist. I work in building coupled regional climate models. That is a model that includes a numerical model that simulates the atmosphere, a numerical model that simulates the ocean, numerical model that simulates the land, and other smaller models that simulate, for instance, river runoff, and storm surge, waves and things like this. And all these models, all these numerical models work together. That's why we call it coupled. It's crucial if you really want to have not just a very good understanding, but also a very good prediction skill towards future events. In our case, we try to push the resolution of the model to be very, very fine. We set up a real-time forecast system for the Gulf of Mexico, and this will allow you to resolve features in the atmospheric circulation, say the winds, the low-level winds, say the ocean currents, say the way the ocean reacts to a coming storm or a hurricane throughout the Gulf, to quality and to a resolution that is really, really unheard of. When Hurricane Isaac hit the Gulf exactly 7 years after Katrina and hit New Orleans, it was a good test for our model because our real-time forecast model was actually running at the time. I was looking at the National Weather Service bulletin, and the predicted path wasn't exactly the same. Our prediction was the Isaac would turn to the west a little bit and stall as he hit the Louisiana coast. So I was quite surprised to actually discover that this was actually what happened. So it was probably a eureka moment, because it was very surprising to see that our model could actually simulate so precisely the path of Hurricane Isaac.
Their most sophisticated models were not yet ready during the Deepwater Horizon disaster, but Raffaele and his team's coupled forecasting models will be a crucial tool for responding to future oil spills.
It was important to help scientists work on the understanding of the Macondo oil well consequences. But it's also important in the future, because if you have coupling between models, especially between the ocean, which it's a much slower moving system, and the atmosphere, which is a fast reacting system. If one of them is not right enough, then you understand that the effect on the ocean surface will be different. And the difference will cause another difference in the way you can predict the spread of the oil in the ocean. So I think it is crucial that now that we have the computer power to actually run this coupled model, we do this more often. So that's what I can do if there is an oil spill. We do actually have a real-time forecast system that I set up. We have a better model now. So in the case there is an oil spill, we are actually able to give some more accurate prediction of a possible spread of hydrocarbons in the Gulf.
Today, thousands of scientists, oceanographers, chemists, engineers, biologists, are all working together to develop newer and better ways to understand and ease the impact of oil spills. To learn more about their work, visit our webpage at dispatchesfromthegulf.com. Funding for this podcast was provided by a grant by the Gulf of Mexico Research Initiative. And thanks for listening.